Hi everyone. So today we're going to talk a little bit about rate of reaction. So in this chapter, what are we studying is we are studying how a certain quantity in the experiment changes with time. So the one that we like to focus on is generally the volume of gas that gets produced over time. So if you look at this experiment here, okay, so look at the axis first. Okay, so when you look at the axis, this is the volume of hydrogen against your time graph. So this graph tracks how much volume of gas is being produced over time. So if you follow the yellow color graph, okay, you will see how much gas is being produced over time. Okay, so now if let's say you want to track the rate of reaction, you can follow the rate path, okay, at let's say 3 seconds. Then draw a tangent over here on the curve path, and then you can calculate the gradient of the graph at that point in time. And that will be your rate of reaction. Okay? So moving on to the next page, okay, how does a reaction occur? For the reaction to occur, okay, there are two conditions you must meet. The first condition is that you must have sufficient energy, or what we like to say, activation energy. Okay, so only when you have sufficient energy, then your reaction can occur. The second thing here is the position of your molecules. By position of molecules, we actually mean more so of the orientation of your particles. So when particles collide, they must actually collide in a correct manner with sufficient energy, right? And only after we have satisfied these two conditions, then we can call it a effective collision. Okay, so over here in this chapter, we're going to explore the first three factors that actually affect your rate of reaction. So temperature, surface area, and concentration. Okay, so let's take a look at temperature. So when it comes to temperature, temperature is directly proportional to the kinetic energy of molecules. Okay, so over here, if you take a look at the words, when temperature increases, your kinetic energy will increase, your velocity of the molecules will increase, and the frequency of your effective collision will also increase. And therefore, your rate of reaction will increase. So if you take a look at the graph here, you can notice that a 60-degree graph tends to be a lot faster compared to a 30-degree graph. Okay, so you have no questions. Let's take a look at the next part on your surface area. So over here, the finer the particles, okay, the greater the total surface area. So what do I mean? Come, let's take a look at this first. Okay, so just looking at the red color highlighted portion, okay, this is a cube that is 2 by 2 by 2. So you realize that the surface area for each face will be 4. And because there's 6 faces, I'll multiply it by 4. And my surface area is 24 units here. Right, but if let's say I was to cut this cube up, okay, into smaller pieces, you'll realize that there will be 8 smaller pieces. So for each of these smaller pieces, the surface area will be 1 for each face. I have 6 faces and 8 cubes, so my total surface area would arrive at 48. Okay, so you'll realize that your total surface area has increased if you cut your bigger object into a smaller object. Okay, so now let's go through some words here. So when it comes to the words, we have powder, granules, and chunks. So powder does represent the finer particles. Granules is a little bit bigger, and chunks will be very big pieces. So when it comes to the word explanation, you need to tell me that when you use something like powder, there will be an increase in surface area to volume ratio, and therefore the frequency of effective collision increases, and the rate of reaction will also increase. So you realize here that for the powder, you will be a lot faster compared to the reaction that contains chunks. Okay, so now right for the next page, okay, so after this, usually I'll give them questions. Okay, so you can skip all the way down to the MCQ first. Okay, so you can give them the ones that are highlighted in red here. So question 5, question 9, 12, 13, and 15. Okay, 23, and then the last one will be 50. Okay, question 50 over here. Okay, so once they are done, then you can go back to the concentration page over here. Okay, so I'll skip page 6, I'll go to page 7. Okay, come. So let's talk a little bit about concentration. Okay, so when your number of moles are, when it comes to like two different experiments, okay, your number of moles should be kept the same if you want to compare the effects of concentration. So meaning, right, that if your concentration is higher, use less of it, and if your concentration is lower, you use more of it. Okay, so to give you a very simple case study, okay, just look at these two experiments. Okay, first I kept the moles the same. Okay, then you look at the concentration. You'll realize the one that is more concentrated, I use less of it, and the one that is more concentrated, I use more of it. Okay, so the purpose is to keep the moles the same first. After you have done that, then you can take a look, at this experiment. You'll notice, right, that the one that is higher in concentration will actually be a bit faster. Okay, so let's take a look at the writing. So when there's an increase in concentration, okay, there's an increase in the number of reacting particles per unit volume, and therefore there's an increase in your frequency of effective collision, and therefore your rate of reaction will increase. Okay, so you can see that this graph is a lot faster for those that are more concentrated. Okay, so for the next part, okay, let's take a look at this. Okay, so just now, right, or for most of the experiments that we've been doing, your number of moles is actually kept the same. Okay, so if your moles are kept the same in different experiments, you will always end up at the same level. Okay, so over here, you can see this is the graph that you've been used to for the past few parts that we were doing. But now, okay, let's say if your number of moles is not the same anymore, you'll realize the ones with the greater number of moles, okay, the experiment with greater number of moles will end up at a higher level. So if you take a look at the two shapes of this graph, okay, pay attention to the higher level graph first. Yeah, you'll realize these are all higher in moles. Okay, now, right, looking at the same graphs that we're talking about, look at the rates. Okay, you'll realize that this one on the left is a little bit faster, and the one on the right is a little bit slower. Okay, so this will be the two shapes of graph that you should also be used to apart from the rest. Okay? Okay, so if you're okay, right, then let's take a look at your case study. Okay, so to give you a very short case study, just pay attention to the right hand side first. So if you look at two experiments, one of them, okay, will actually have higher moles. So this will end up at a higher level. Okay, next you compare the concentration, you'll realize the one with a higher concentration will be a bit faster. So that means the first graph, the first experiment, will have a faster reaction and end up at a higher level. Okay, so this is how I will look like. Okay, higher level, faster reaction. Okay, and based on this, the explanation is exactly the same as before, so you can take a look, and then now you can try some questions. So at this point in time, I'll give them some MCQ. So you can see question 7. Okay, question 24. Okay, question 32. And then question 43. So after they are done with the MCQ, right, you can actually jump into this question here. So once they have done everything, this is a long question. This is from 2 pages long. But part A and part B focuses on other chapters. The main focus is actually on part C that talks about your rate of reaction. Okay, so once they have done this, right, you can get them to do this question here. Okay, so over here, I will don't look at the bottom at all. I'll just tell them, okay, over here in this graph, do you see 5 different graphs? And do you see 5 different experiments here? So I just want you to link the 5 experiments to which graph they belong to. Okay, then after that, that's more or less the end of this lesson. Okay, so just now, right, I actually missed out one question. So over here, after the part where you talk about temperature and surface area, you can actually add this question in after the MCQ as well. Okay, but same thing, right? The part B and part BII is actually focusing on the different chapter also. So the main focus is you can get them to either do part A, right? If not, the part 3 is the more important part here. Okay? If not, then that's the end of this chapter.